October 2022, the United States Commerce Department published 4 pages of export restrictions that made it illegal to sell Nvidia's most advanced data center chip to any buyer in China. Inside Zhongguancun Science Park in Beijing, engineers reportedly printed those pages and taped them to a whiteboard. Not as a compliance notice, as a to-do list. The chip was gone. But 15 years of accumulated software underneath it, the libraries, the framework integrations, the career knowledge baked into millions of trained engineers worldwide, none of that appeared anywhere in the rule text. The stack had 2 layers. Washington regulated one of them. This is the story of CANN, Huawei's compute architecture for neural networks, and how a software runtime became the most consequential response to an export control that may have targeted the wrong thing entirely. Nvidia's parallel computing platform launched in 2006. What followed over the next decade and a half was not just software development. It was an accumulation of optimized libraries covering linear algebra, deep learning primitives, and signal processing, plus native integration into every major research framework including PyTorch and TensorFlow. The overwhelming majority of artificial intelligence researchers globally trained on this toolchain first. Their intuitions, their debugging instincts, their mental models of how computation flows, all of it is shaped by one ecosystem. Think of it as the plumbing standard inside every building in a city. You can ban the sale of a specific brand of pipe fitting, but every plumber already knows one threading system. Every tool in every van is cut for it, and every building in the city was designed around it. Swap the fitting, and you are not replacing hardware. You are retraining an entire trade. Switching away from this ecosystem requires rewriting or retesting, not just model code, but the operator level layer underneath it. A task measured in engineering years per institution, not engineering weeks. Huawei understood this before the export rules existed. CANN had been in active development since at least 2019. The software response preceded the hardware ban, which means Huawei was not reacting to the October 2022 rules. It had already diagnosed the real structural problem those rules would eventually expose. CANN provides operator libraries, a graph compiler, and framework adapters that sit between artificial intelligence model code and Ascend silicon. It also includes a compatibility layer designed to accept code written for the dominant ecosystem's application programming interfaces and translate it for Ascend hardware. Developer community reports describe partial but incomplete compatibility on complex workloads. Major Chinese artificial intelligence institutions, including labs at several universities and domestic cloud providers, have publicly confirmed integrating CANN into at least portions of their training pipelines, though third-party audits of that integration depth are not publicly available. The compatibility layer works like a voltage adapter. It does not change the underlying electricity, but it lets a device built for one standard run on a different grid. The question is always whether the adapter handles full load or only the simple cases. If you printed the accumulated library commits from 15 years of the dominant ecosystem double-sided at standard page density, the stack would run taller than a 10-story building. CANN is attempting to cover that ground in roughly 5 years. That gap is real, and it matters. But the surface story, that Huawei built a software toolkit, obscures what is actually happening one layer down. The chip ban removed a fast processor from the Chinese market. Huawei's Ascend 910 series is the domestic alternative, and by Huawei's own claims, it is competitive on specific large model training tasks. No independent benchmarking organization has confirmed those figures under realistic production conditions, and I will return to that. But even granting the chip gap is real and manageable given enough time and volume, the structurally harder problem was always the software gap. CANN is not trying to win a benchmark. It is trying to make the benchmark irrelevant by raising the cost of staying on the existing ecosystem above the cost of migrating off it. The deepest layer is what that migration path does to the export control's underlying logic. If CANN reaches sufficient coverage, Chinese artificial intelligence infrastructure becomes resistant to sanctions at the software layer, meaning no future hardware control, however precisely targeted, can recreate dependency leverage. The export control did not merely fail to eliminate the existing software moat. It funded the excavation of a parallel one. Washington treated the dominant chip as a strategic asset, the way a general treats a tank. One object, one capability, remove the object, and the capability disappears. But a software runtime is not hardware. It is closer to a language. You do not embargo a language by impounding the printing press. That category error is, in my reading, the central strategic miscalculation embedded in the 2022 controls. Now the Steelman, because this argument has real vulnerabilities and they deserve direct treatment. First, every performance figure in this ecosystem comes from Huawei or from institutions with clear incentives to validate domestic alternatives. No independent machine learning benchmarking organization has published a comprehensive comparison under realistic production conditions. The historical gap between vendor claims and verified performance in artificial intelligence hardware is large. Second, the compatibility layer handles common cases. Frontier model research lives at the edges, non-standard operators, experimental architectures, custom low-level kernels. Developer reports from those attempting to port cutting-edge research workloads describe significant friction that does not appear in headline numbers. Third, Ascend silicon is manufactured at process nodes that trail the leading edge by a measurable margin, a consequence of separate restrictions on advanced lithography equipment. More computation per watt still flows more efficiently through chips built at tighter geometries. Software abstraction does not cancel thermodynamics. Taken together, CANN is a credible long-term bet with a real near-term gap, and anyone who collapses those two time horizons into a single verdict is selling you something. I want to be honest about my own read here. I find CANN genuinely impressive and genuinely unproven at scale. Huawei's own benchmarks show competitive throughput on specific transformer workloads. No independent lab has confirmed those numbers under production conditions. Impressive and verified are not the same thing, and I will not pretend otherwise. What could the United States have regulated that it did not? Export controls apply to goods, technology transfers, and some software with a direct defense connection. An openly published commercial software runtime does not obviously meet existing criteria for restriction. The dominant research framework, which is the platform most Chinese artificial intelligence engineers trained on, is open source, meaning the knowledge it transferred is not something a licensing restriction can claw back. Restricting software ecosystems or developer knowledge at scale would require a legal architecture that does not currently exist and would face significant opposition from technology companies with global developer communities. The Commerce Department's jurisdiction, in practical terms, stops at the hardware layer, which returns us to the callback. The stack America chose to protect was always the hardware floor. The layer that accumulated the actual structural power, 15 years of trained engineers, the library surface, the framework integrations, was never on the restricted list. CANN is the direct consequence of that omission. The sanctions may have been strategically coherent if the goal was slowing Chinese artificial intelligence development by 2 to 4 years. What they appear not to have modeled is that the forced detour would require Chinese labs to build infrastructure that is, by design, resistant to the next round of controls. The wall bought time. It also drew the map. CANN is not a finished product. It is a declared intention backed by institutional resources and a migration incentive that grows larger every time a new hardware control is announced. A restriction meant to contain Chinese artificial intelligence by removing a chip instead clarified exactly which problem needed solving. The wall did not stop them. It specified the door. The most effective sanctions in history targeted what a country needed most and could not build alone. Somebody in Beijing read that history, and they did not wait to find out which layer that was. If CANN achieves production parity on large model training, not benchmark parity, actual deployment parity, does the chip ban end up accelerating Chinese artificial intelligence independence faster than no ban would have? I want to know what you think in the comments. If this kind of analysis is useful to you, subscribe. The next video goes deeper into Ascend's hardware architecture and what the node gap actually means in practice.